Let's completely skip the fluff and jump straight into a surgical fix of a broken Cambridge IGCSE computer science answer. Look, if you wrote the answer we're about to dissect in your exam, you literally just threw away free marks. So today, we're operating on exactly why that happens, what examiners are actually hunting for, and how to engineer the perfect response that guarantees you top marks.
Okay, look at this sentence right here. Clock speed means the CPU is faster and does more instructions. I mean, it feels like a safe, standard response, right? Because colloquially, it totally makes sense. Ask anyone on the street and they'll tell you a higher clock speed makes a computer faster. But guys, it is a massive trap. Writing this instantly loses marks. It destroys your exam timing and frankly puts your final grade boundaries at serious risk. Under the pressure of the clock, writing something that just feels true in everyday language but lacks strict scientific precision, that's hands down the most dangerous trap in the entire 478 syllabus.
So we're going to operate on this exact paragraph to show you exactly why ordinary revision completely fails in this syllabus. The core issue here? The examiner literally cannot award marks for a label without a mechanical process attached to it. They're not looking for the word faster, no way. They're looking to see if you actually understand the fetch, decode, execute cycle. Think about it. The clock inside a CPU generates billions of electrical pulses per second. Each pulse governs one step of fetching an instruction from memory, decoding what it means, and executing the logic. A 3 gigahertz processor, that's performing 3 billion of those cycles every single second. If your revision only goes as far as clock speed equals faster, you are completely skipping this internal mechanism and leaving 0-mark landmines all over your paper.
And Ossol's material explicitly outlines the ultimate rule of the mark scheme here. Generic responses rarely gain full marks. You lose points when you know the theory perfectly well in your head, like you know generally what a CPU does, but you fail to anchor your explanation to the exact details provided in the question. A top band answer? It requires you to use precise terminology, explain the internal processes crystal clear, and critically, apply that theoretical explanation directly to the scenario you've been given. In a moment, I'll show you the exact examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious. Because trust me, once you see how this framework structures your thinking, spotting that clue becomes absolute second nature, and those lost marks instantly become guaranteed points. All right, let's dive into a highly reliable 4-prompt memory structure that shifts your knowledge from basic textbook recognition to high-mark application. Whenever you revise a concept, don't just blindly memorize the definition. Ask yourself, number 1, what is it? 2, exactly how does it work under the hood? 3, where is it being used in this specific scenario? And 4, why is it better or worse than an alternative? Take a second to really process that. If you can answer these 4 prompts out loud, your conceptual knowledge is bulletproof for the exam. If you can't, well, you need to rebuild the topic using a worked example.
So let's actually apply this framework to a realistic digital scenario to diagnose the exact requirement of the task. Imagine an embedded system inside an autonomous robot. We aren't just talking about a boring desktop computer sitting in an office anymore. This robot is navigating a warehouse. It's actively pulling in LiDAR and ultrasonic sensor data. We have a very specific requirement here: real-time data processing, so it literally doesn't crash into a wall. This is exactly how Cambridge tests your ability to transfer theoretical knowledge, like that fetch, decode, execute cycle, into a practical, high-stakes environment.
Now, what is truly fascinating about this comparison is how the top-band answer actively connects the theoretical process straight back to the robot's context. Look at the flawed answer. Higher clock speed makes the robot faster. It's completely generic. But listen to the top-band answer. Higher clock speed processes more sensor data cycles per second, ensuring real-time robot navigation. Do you see the mechanical difference there? It connects the CPU cycles directly to the sensor data and the critical need for real-time navigation. That context anchoring, that is your key examiner clue. Right now, I want you to mentally pull up your most recent practice paper. Pause for a second and predict your own score, based on what we just learned. Did you just name drop a device? Or did you actually explain how its internal process works? Did you give an advantage with absolutely zero technical reason to back it up? Here's the harsh truth. If your answer could apply to a smartphone just as easily as it applies to an industrial robot, it is completely missing the critical context layer that examiners require for top marks. And this brings us to an absolutely crucial point: avoiding these classic wrong turns. If the context of the question is a school, an office, a local area network, or a cybersecurity incident, your answer must stay strictly locked inside that specific environment. The most common errors we see come from vague wording, entirely missing internal process steps, or, and this is a big one, writing an incredible, highly technical explanation that completely ignores the scenario provided.
You have to diagnose what the task is actually testing. Is it logical reasoning, hardware selection, or a mechanical process explanation?
Let's move to this next concept and build your analytical safety net. Your theoretical foundations completely depend on distinguishing between nearby concepts. In the heat of the exam, learners so frequently confuse memory and storage. Remember, memory, like RAM, is volatile. It's the active workbench where your CPU temporarily holds the instructions it's actively processing right now. Storage, like an SSD, is non-volatile. It's the filing cabinet for long-term retention. If you write that a faster clock speed gives a computer more storage, you fundamentally misunderstand the architecture and score a big, fat 0. The exact same goes for mixing up a compiler, which translates entire source code all at once for faster execution, versus an interpreter, which translates code line by line, making it much easier to debug. Your dense revision notes must actively train you to contrast these components. To build that analytical safety net, notice the progression of this ultimate 3-pass revision cycle required to dominate this syllabus. The first pass, it is entirely about securing your key definitions and contrasts, like knowing exactly how RAM differs from a hard drive. The second pass is where you rehearse those worked explanations and map out the internal processes. And the third pass is all about exam adaptability. This is where you practice changing the scenario, mixing up similar terms, and forcing yourself to justify your technical choices in a completely new environment. This layered style is absolutely vital because Cambridge questions constantly combined theory with applied reasoning. So before you submit any exam answer on clock speed and performance, use this exact checklist to ensure you haven't given a benefit without a scientific reason. Ask yourself, did you clearly explain the mechanical causes, the downstream effects, or the specific design decisions? And most importantly, did you do it firmly locked inside the context of the question? Specificity and context, guys, they are the only ways to consistently achieve the highest marks on these papers. But what happens if you try to apply this framework and accidentally confuse memory with storage on exam day? Well, that single mix-up collapses your entire explanation. To prevent that absolute disaster, your mandatory next step is to use our last 7 days revision map explainer to connect these topics flawlessly. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that explainer right now, and let's go secure those final grade boundaries.